Up until now, we have demonstrated working with the CAS Web API and Signature Pad API with Postman, which is actually theoretical work. In this video, I want to present a real project that works with the Signature Pad API and to do a code review with you to demonstrate how to work with the API in the real world. You can browse to this demo website at www.biotrust.online, which allows enrolling a signature profile and do verifications afterward. You should browse to this website from a smartphone because a touch screen is required in order to input our signatures. In this demonstration, I will use a desktop browser. I want to show you how it works, so for this purpose I will simulate a smartphone browser. This demo site is currently support English and Thai. We will work in English. We have here a few words about biometric signature and how it works, and a button to start a profile enrollment. Moving on to the enrollment, I need to insert a name or a profile description, which is not mandatory. Only if I want, but it's convenient. And an email address, which it is mandatory. By clicking on the Sign button, I will be redirected to the Signature Pad API website with the query string parameters we have talked about in the previous lesson. As we have seen, if I hold the smartphone like this, I'm getting this animated GIF asking me to rotate the device. And when I do, I also need to go full screen mode in order to have more screen space for signing comfortably. We can see at the URL here that we have been redirected to the Diamond Docs info domain in English, to the Signature Pad API section inside this domain. The command is enroll. And you can see here the disposable tokens that the website received behind the scenes from the CAS Web API for this session. And also we can see here the callback URL value in a URL encoded format. http www.biotrust.online, summary, enroll, and I'm also returning myself the disposable token so I could find out back in my home page for which user the process was done. So, right now I'm in the enroll process. So let's rock and roll. The server checked out all my signatures to ensure that they are consistent enough to create a signature profile, and let me know that I've completed this enrollment successfully. Once I will close this message, I will be redirected back to this callback URL, back to the home website, back to the demo website. So I'm closing this message and returning back to my home page. Behind the scene, the home page has noticed that I'm back from the enrollment process, and it checked with the CAS Web API the process status by sending the disposable token as a parameter. And I can see here that my enrollment completed successfully. I've also got here the profile name, which by the way has not been saved to the database. I've got a profile GUID that should be somehow connected to the name. I do it by creating here a verification link, and I'm inserting the profile name and receiving GUID on this link. Here we can see the email I've got. I have here a link to do verification and also a link if I wish to erase the profile from the system. So let's click on the verification link and simulate smartphone. And you can see you've got the profile name and GUID in the query string already copied to the appropriate fields, and I can go on and click the button for verification. Once I click the button, This site will request a new disposable token from the CAS Web API, will build a callback URL, and will redirect me again to the signature pad API website. So here we are again at the Diamond Docs info signature pad section. This time the verify command, and we can see also the callback URL for redirecting me back to the home page on completion. We can see here the verify keyword, so I will know that the user just came back from verification and not from enrollment, and act accordingly. I'll try to sign one signature that doesn't match the profile, and one more signature that does match. This one also fails. Let's try one more time. This is better. I've came back to the home site, and again the disposable token was checked against the web API, so that the verification succeeded, and that's what I'm getting here as a result. Another thing I can do with the links in the email is to raise my profile. Let's try it. I need to confirm it first. Let's simulate a smartphone again. I confirmed, and profile successfully raised. Now if I'll get back to the email and try to run verification process one more time, I'll sign. And profile not found. Actually, this website could be a little more clever and check for the profile existence with the CAS Web API before the redirection to the signature pad website, saving me the redundant signing and displaying the profile not found right away. So you can take this flow improvement on yourself as a challenge or a mission when you download this project. Now let's do some code review. This is the CAS Portal project. I have here helper directory, and inside that directory I have this class called Web API Helper. And this class wraps up the functions that I need when calling the CAS Web API. Let's start with the last function. Request CAS token. Here is about the main token or access token, not the disposable one. This is the main token that identifies me as an organization in front of the CAS server authentication mechanism. So this function has no parameters and returns the actual token. It's done by reading my credentials, which is the username and password, or rather the organization code and password from the config file. The credentials are encrypted in the config. So the first thing the method does is to decrypt the data. I'm using here the .NET protected data class and the unprotect method. When the credentials are written in this format, username, pipe, password, and it was initially encrypted using both the entropy and the current user restriction, which means that only the current user that runs the system and the entropy data embedded in the system code, only the combination of the user with the embedded entropy will be able to decrypt the credentials from the config file. This is the mechanism that I use in order to encrypt sensitive data needs to be written to the config. In order to encrypt the data, there is a small utility here, which I'll include in the download package, called config key protector. I've written this tool and you're allowed to use it too. Generally, I need to insert here the entropy. I've got here the base 64 representation of it. So I'll just copy and paste it to the field and insert the username and password and the value field. Now I'll click encrypt. This is the value that I need to copy to the config file under the credentials key. Once the method is called, this part is doing the same action but in reverse order. It's like I don't have this value, and I'm calling decrypt, and I'm getting the decrypted credentials. Here I'm inserting the credentials parameters to the request, the username, the password, and not forgetting grant type as well, which is actually equivalent to this command in the Postman. Username, password, grant type. I'm getting the access token in the response to this request. Same thing here. I'm executing the request, and if I get a valid response, I'm deserializing from the response content the access token field via JSON and return it back to the caller. By the way, if you're running this project under IIS, in order to get the right encrypted value for the config file, you need to run this utility under the same user that runs the application pool. You can do it by holding the Shift key and right-click on the executable and selecting Run as different user. Then insert the same credentials of the user that runs the application pool. Only then you can encrypt the credentials and get them back properly over here when running the system under the same user. Other functions that we have in this class. The first one is get disposable token. This function is equivalent to the action we took in the last video of getting the disposable token for a particular ID value that we have provided. What I need to provide is the access token to identify my organization, and I'm requesting in get signature pad disposable token and the ID that I want to redirect to the signature pad API for processing. The ID of the user, of course, that I want to redirect. So we have here a similar request in the method. I'm getting the CAS domain from the config, adding the API, signature pad part, and requesting a disposable token with get verb for a particular ID, which I got as a parameter in this method. What I'm doing next is calling the execute authorized request method. This is actually my own extension to the REST client class of the REST sharp library. When calling this function, I'm passing the request object, same as the ordinary execute call with the REST client. Here I'm calling the execute authorized request. So on top of the request object, I'm also passing the request CAS token methods as delegate. Notice I am not passing the result of the function, not the token itself. I'm not calling the function for the result, but passing the function itself as a delegate. This function is a custom extension. What it does is the following. The function doesn't know what the access token is, but it knows how to get it when required. And to receive the token, it's invoking the delegate. So I have here a static variable called token, which is the access token. Only in the first call to this method after the system is up and running, this field will be null. So this delegate will be invoked to receive the actual access token and store it in this field. The static field will store the token as long as the site is up and running. Then it continues by adding the authorization token to the request. Same as I did here in Postman. Header, authorization, bearer, and the token. Now I can run the execute method of the REST client when I have the authorization already in the request. Now, if I get back unauthorized response, I know that this token is probably expired. So in this case, I'm removing the previous authorization header invoking the delegate again to get a fresh token, adding it again to the request header and executing the request one more time. Here, I'm not checking again if the request was authorized or not. If it's not authorized by now, there's probably a different problem. There's no point to get a fresh token again. Same thing for other errors, in case there is any on the response. The caller should handle it. The only duty for this method is to execute an authorized request and return the response as is. Since the CAS token is valid for 21 days, I don't bother to deal with the expiration date, save it and check it before I execute the request. I just let myself to make once in 21 days an unauthorized request and get a fresh token when needed. If it was a short-term token, I would handle it differently and checking the expiration date before executing the request. So this is my technique to execute an authorized request by passing this delegate that knows how to get an access token only when required. Another custom extension method I've got here is the get error message. Because it's not always so simple to get the right error message from the response, because it also depends on how the server side handles and returns errors. So this method checks all kinds of fields in the response object to get the most appropriate error reason in case of the request failed. This is my custom extensions to the REST shop library. Okay, so here I request a disposable token, and if I'm getting a valid response, I'm extracting the disposable token that I've got, which is right here, and return it to the caller. Otherwise, I'm throwing an exception with the most appropriate error message that I can get. The next method is get enrollment results, and it works very similar to the previous method. I just construct the right URL for the web API, passing the disposable token that I've got as a parameter. Again, I'm calling the get authorized request with this method as a delegate. And if I'm getting a valid response, I'm deserializing the response content to this object. This class here is a match to the JSON response I'm getting from the enrollment result method, and I return the result object back to the caller. Same thing on the next method, get verification results. Again, I'm constructing the URL, calling this time to verify results on the API, passing the disposable token, and executing an authorized request. If done successfully, I'm deserializing the response content to this object, which matched the JSON result object received from the web API, and return it back to the caller. Here I have another method that allows me to delete existing profile. This time I'm not getting a disposable token as parameter, but rather the profile GUID value. This profile already exists and of course belongs to my organization. I'm constructing the right URL with profile, erase. You can see the methods here on the API help page. Next, I'm executing an authorized request, and if done successfully, return this object, which is delete profile result. Okay, this is my Web API helper class, which contains all the methods I need in order to interact with the CAS Web API server. The next thing I want to go through is the controller. This controller is the component that gets the request and sends back the right view or a page to the browser. and also doing behind the scene all the required action. Let's go through the methods while surfing the CAS Portal website. I will run this site directly from the project, locally, on the local IIS Express. Okay, this is the home page, or the index view, and I'm clicking this button to get the enrollment page, right here, this one. Once I click this sign button, what's happening is executing the post methods of the enroll page. Okay, let's take a look at the methods. Here is the post method of the enroll, and I'm getting here a registration model. This object is containing the name and email of the signer. Here is what's happening behind the scene. First of all, because I do not work with database on this demo site, I'll create a totally random number for ID that I will work with in this session. I'm creating here an instance of the Web API class that we have discussed earlier. The matter of the fact is that in the real-world web application, I would use some kind of injection technique, probably with an inject library, in order to inject this instance to the controller, not to create it explicitly inside the controller, as it's not the controller responsibility to do it, and it will make it easier to unit test the controller. But for this demo, it will do. Here I'm asking the helper instance to get the disposable token for the enrollment session with this random ID. After that, because I don't use database in here, I just temporarily save the email in the application cache with the random ID as a key, and if I get the name with the request, I also cache it as well. This is the way I create a connection between the email and the user. The next step is to construct the callback URL needed for redirecting the request to the SignaturePad API website. First, I'm dynamically taking my own current domain, which will be in this case the local IIS Express domain. When the site will run under a public domain, it will be this domain. Okay, where do I want the SignaturePad API website to redirect after finishing the process? So, redirect back to my domain, go to summary, tell me that you just finished the enroll process, and give me back the disposable token that was used to this enrollment. When I'll get this call, I would know to check the enroll status for this particular token and get the ID as well. Here I'm choosing the language for the SignaturePad website. You can just add EN for English. Now I'm constructing the URL for redirecting the browser to the SignaturePad website. The first part is the CAS domain. The language, and this time I'm not using the API, but the SignaturePad. I want to enroll for this disposable token, and the callback. Return back to me when done to this URL. By the way, this URL callback value is URL encoded, as I've demonstrated on the last video, in order to be recognized as one segment by the CAS server. And finally, the actual redirect command to the SignaturePad API website is here. All of it will happen instantly when clicking the sign button here. And it did. I was redirected to the SignaturePad API website, and I will make the enrollment. And as requested, it redirected me back where I wanted, my domain, summary, enroll, and send me back the token as well. Here is the summary method. The mode here is enroll, and I'm also getting the token as a parameter. Okay, so here is what's going on the summary method. I've created again the instance of the Web API helper class, which I use to call the CAS Web API. Since I'm in enroll mode, I'm asking to get the enroll result from the API helper instance, and I'm getting the result as enrolled result object, which is identical to the CAS Web API JSON object as we saw earlier. Here I'm doing some language-based conversion with resource for the OK result, just for friendly display to the user. Now, if I get here a profile GUID, it means that I have a new profile. So I contrast two links, one for verification and the other for deleting the profile. Again, I'm getting my own domain dynamically, in this case, the local domain. So there is the website, go to verify command and pass the profile GUID and the profile name, if there is any. Similar thing is done for the erase link, also adding the profile GUID and the name. The next thing is to send the formatted message with those links to the user email address, which I get from the cache with the ID number as key. This is how the email message looks like. You can see the local IIS Express domain in the link. And you can see also the profile name and GUID. I'm also getting the erase profile link right here. Once I click this link in order to start the verification process, the browser is taking me to the verify page. I have the profile name and GUID in the fields already taken from the query string in the URL. The name is optional. If I remove the name, it will also be alright. Once I click the sign button, I will get to the verify post method. Let's take a look. First check is to see if the valid GUID is received. The name is not playing a role here. Again, creating an instance of the Web API helper class, requesting disposable token for the profile, which is actually the CAS profile GUID, and again constructing the callback URL for the post-verify process. This time I want to get the verify mode, not the enroll mode I asked earlier, and passing the disposable token as well. Checking the current language, setting the full redirect URL to the signature pad API website, and executing the redirect command. As expected, I was redirected to the signature pad website for signature verification. Let's sign. Maybe I'll just add some scribble first. Not accepting. Try again. This time accepted, and returns me back to my website. The summary page this time is verify mode, and also adding the disposable token value. Here is the summary method. This time the mode is verify, and I'm checking the verification result with the CAS Web API, providing the disposable token I got in the query string and displaying the results to the user. Those are in fact the primary functions of the CAS Portal system. And this is the right technique, my technique at least, to work with the signature pad Web API in conjunction with the CAS Web API. As I've mentioned, this project can be downloaded, including the config key protector tool. The link is in the description. I hope this session was helpful to you. Thanks for watching.